So viewers, today I discuss new ideas about the form of the infinity. What infinity is, we already know in my earlier videos, and we have some of the idea about infinity. It is a larger than large and smaller than small number. But now I discuss what will be our result and how to tackle the situation when we find infinity to the power 0 and infinity by infinity. This is very much interesting, and how to solve this result we discuss today this video. So let's watch this video till the end without skipping. And the viewer who are watching this video first time, they subscribe the channel and press the bell icon to get all the notification and latest update of my video. Let's watch. If we say our result that limit as n tending to infinity and n to the power 0, what will be our result? But apparently it appears that if we considering a large result and that's power 0, certainly it will looks like 1. But it is apparently appears that these things happen. But it is a case of the form. And if we say this type of result as limit x tending to infinity, suppose another function like this fx to the power, if we say better to say that fx tending to infinity fx to the power gx, and this result will come, and this if gx result, that is another function, and say like this gx tending to 0. So what will happen this result in these cases? But it looks like an indeterminate form. This is not actually 1, this result is indeterminate form. So this categorical situation appears when we are solving some of the cases and some of the limiting problem. And when we are tackling this type of situations, we apply some of the techniques. How to apply these techniques? I will discuss this video, watch it. Suppose if we consider limit as x tending to infinity, x to the power 1 by x. But if we look like this type of situation, certainly it will be infinity to the power 0. Then how to solve this result? To tackle these situations, if we take as our consideration, let as consider y is equal to limit as x tending to infinity x to the power 1 by y, and now taking logarithm ln y, and that will be limit as x tending to infinity 1 by x ln x. And now it is also infinity by infinity concept. There is also the form of infinity by infinity. And now if we are taking by L'Hospital rule, limit as x tending to infinity, derivative of this, so it will be derivative, that is a ln dash by derivative of 1 by x. This is our result by L'Hospital rule. Now we are writing limit as x tends to infinity, minus derivative of 1 by x, that is 1 minus of 1 by x into derivative of ln x, that is 1 by x into minus 1 by x square, and it will looks like this minus of limit x tends to infinity 1 by x cube, that is 0. Now ln y is equal to 0, that is y is equal to e to the power 0, and it will be 1. So finally we write limit as x tending to infinity x to the power 1 by x, that result goes to 1. So in this way we tackle this situation. Now let's watch another form, infinity by infinity. Suppose if we are taking limit as x tending to 0 sine 1 by x by 1 by x, what will happen this? And suddenly it will be limit as x tending to 0, and this form will take it like this, infinity by infinity. And now limit, it will be limit x tends to 0 x sine 1 by x, and this goes to result 0. And how these things happen, we may prove by analytically. For given epsilon greater than 0, we have mod of x sine 1 by x, that will be less than equals to mod x, and suddenly mod of sine 1 by x, that is 1, and that will be less than equals to mod x, less than equals to mod x. And this mod x is less than epsilon, certainly it will be looks like epsilon, that is mod of x minus 0 is less than delta, and delta equals to epsilon. So epsilon delta criteria satisfied, and hence we can say our result, that limit x tending to 0 x sine 1 by x equals to 0. So this result goes to finally 0. So it is takes the form of infinity by infinity, and we are tackling this type of situation in this way. We end our discussion today. If you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.